Okay, last week we were looking at compound interest. And we went through the process of going through and calculating that compound interest, but we don't need to do that. You can turn to page 348, and we're going to be using interest tables. So we don't have to go through this process that we did before. Now these interest tables the compound amount of the future value is a table factor. So if you look on page 348, you will be determining what is the percent for a period, okay? And remember, we had to break it down if it was semi-annual or if it's annual or quarterly. That's number of periods times the number of years. We could get the number of periods and then the number of the amount of the percentage. And where they intersect is going to be the factor. Now, the table on page 348, and if you would hold that spot and flip over to your table on page 358. Oh, did you? Thank you. And so on page 348, the table that is there, and if you look at the first column, the 0.5%, and the first period, number 1, you see the 1.00500. And then if you look at the one on the page 358, the first one is 0.99502. These factors are reciprocals of each other. And what that means is that if you take and divide the factor into 1, like in the table that's on page 358, or I'm sorry, this is on 358. If you take that first factor, 0.99502, and divide it into 1, what you get is a factor that is on page 348, which is 1.00500. Okay. The same thing, if you take and you divide 1 by this 1.00500, you're going to get this factor that is on the first factor on page 358. So they're reciprocals of each other. Okay. And so we will still have to find out the table factor, the compound future value, by taking the table factor times the principal. But we'll need to know the compounding periods, the years times the periods per year. And then the interest rate is nominal rate divided by the periods per year, or nominal rate's the same as annual rate. Okay. Now let's go back over and look at our periods again. And if it's done compounded annually, then we're just getting it once a year. Semi-annually, we're getting it twice a year. Quarterly, we're getting it 4 times a year. Monthly, we would get it once a month. It'd be 12 times during a year. Daily, 365. If it's continuous compounding interest, it's infinite. And that brings us to how do we use the tables. So this is on page 349. We scan across the top row to find the interest rate per period. And then we look down that column to the row corresponding to the number of periods. And then step 3, we take that table factor at the intersection of the rate per period column and the number of periods row, and that's the future value of $1 at compound interest. And then we multiply that table factor by the principal to determine the compound amount. Okay. So let's look at this. This is going to be the same problem that we did earlier when we had to figure out the compounding where we had $10,000 at 12% interest compounded semi-annually for 3 years. So this is the same problem that we're working with, but we're going to use the tables to figure out what is our compound amount. So the first thing is figuring out our compound periods. We had 3 years. It was semi-annually, so that's 2 times a year. So we've got 6 compounding periods. The interest rate, we had 12%, and we have 2 compounding periods in a year, so it's 6% per year. So the compound amount, let's look at our table on page 348. Look at your table on page 348. And find where the intersection is, where you're looking for 6% and you're looking for 6 compounding periods. What did you find?
On page 348,
1.41852. And you'll multiply that times the principal, which was $10,000. So the compound amount that we're going to receive, compound, is $14,185.20. And remember, to find how much interest that we've made in that compounding period, we take the principal and we subtract it from that compound amount that we found. So the $10,000 minus that, so we've made interest of $4,185.20.
So before you can use the table, you have to get the compounding.
You still have to do the same thing we did before. You've got to know how many compounding periods, and then you take the number of periods per year and divide that into your interest to get that amount per period. So you've always got to find those two to see where they intersect on the table. Okay, sometimes if we have, let me get my table here. Notice that on your table, it only goes to 25 years. So you may have a problem where you have more than 25 years or 25 periods. So you may have 30, 40, 50 periods or whatever it might be. So then you're going to have to do something different. And so these are the rules for that situation when you cannot find the number of periods on your table. Okay, for the stated interest rate per period, find the 2 table factors that represent half or a value as close as possible to half of the periods required. Then you multiply the 2 table factors from step 1 to form a new table factor. Okay? And then you round the new factor to 5 decimal points. So I'll show you how this works. Okay, we need to calculate a new table factor and find the compound amount of $3,500 if we invest it at 6% interest compounded quarterly for 7 years. Okay, for 7 years, correct. So first thing you need to do is find your interest rate per period. So if it's quarterly, you're going to divide 16% by 4, so it's 4%, okay, for each of the quarters. Compounding period, it's 7 years. You're getting paid 4 times per year, so it's 28. Well, we only go to 25, so what do we have to do? It said to divide this in half, so half of 28 is 14 periods. Okay, so look on your table, and you're looking at 4%. Looking at 4%. And you're looking for 14. It's 1.73168, okay? So you will take those figures and you will multiply them together, and so we get a new factor when we round it to 5 decimal places, 1, 2, 3, 4, 5, so we'd round this up to 2. So our new value is 2.99872.
So we multiply value we found in the table times itself?
Yes, yeah, because this is 14 periods and this is 14 periods to make up the 28 to get a new factor, okay? And then you round it to the 5 decimals. And then you take that and you multiply it times the 3,500, so the compound amount is 10,495.52. And then to find out what your interest is, you would subtract 3,500, your original principal, from that to find out your interest, okay? I think the tables are fun to use. Hopefully you will. The main thing that you have to remember is that you've got to get these two things first, and then that tells you what you need to do to find your factor, okay? Okay, the next thing that we want to look at is going to be annual percentage. You probably see this a lot on your credit cards. You'll see the APY on your credit cards if you read all the fine information. And this is the annual or nominal rate. It's the advertised or stated rate of an investment or loan, and the rate used to calculate the compound interest. And the annual percentage rate or effective rate is the real or true rate of return on investment. It is a total compound interest earned in 1 year divided by the principal. And the more compounding periods per year, the higher is the APY. So this shows you if you have $100 at 12% and it's compounded annually, you're getting $12 in interest earned. Semi-annually, you're getting $12.36, quarterly $12.55, and monthly $12.68. So you can see that the more that you have it compounding, the more money that you can make. So let's look at a problem where we're figuring the APY. We need to find the compound amount and compound interest and annual percentage yield of $7,000 invested for 1 year at 6% interest compounded quarterly. So first thing, find your interest rate per period. So 6% is done quarterly, divide by 4, so it's 1.5%. Compounding periods, it's invested for only 1 year, and there's 4 times you're getting paid in that year, so your compounding periods are 4. So your compound amount, find your 4%, 1.5 and 4 periods. And so find where it intersects. So I want you to look on your table and find that.
1.5 and what?
1.5 and 4. It's 4. Number of times that you get paid. 4 periods. Did you find it?
Mm-hmm.
Okay. So it should be the 1.06136. Multiply that times your principal, and the $7,429.52. Compound interest, remember we take the compound amount, subtract out what the original principal was, $429.52, and then to find the APY, we take that total compound interest for 1 year, $429.52, and divide it by the principal. So the the APY is 6.14%. 6.14%. So you're okay so far? Okay. Questions? Okay, we're going to move now. We've been looking at future values, and remember on future values, we were looking at where we had an unknown. We knew how much we were going to invest, and we were trying to see what will it be in the future. Now we're going to be looking at knowing what we want to have in the future. What do we have to invest today in order to get that with the interest rates? It used to be where you could put your money into CDs or money markets and you could do pretty well. I mean, it used to be where you could get some pretty good interest, 13% or so, or whatever. It's not true now. It's very difficult to find places to put your money because CDs don't work. They don't pay anything more. Money markets.
2.5 for a jumbo CD,
Yeah, money markets don't.
or 1.7 or something like that.
Right. It's just, it used to be that you could, if you save some money and put it in there, then you could see it grow. But it's not true anymore. So that's what we're looking at. Again, it's if we wanted 100,000 in the future, and we know that we could get 8% compounded quarterly, then we can find out what do we have to put in today to have that. So these are the steps for using the present value table, same as what we did with the future value tables. You have to scan across the top to find the interest rate per period. Then you look down to find the corresponding number of periods that you're going to be paid that interest. You find that table factor, and then you're going to multiply it times the principal amount that you have, or what the amount that you want in the future, okay, to find what you would have to invest now. So example of present value. So we're going to be using table on page 358. So go ahead and turn there so you'll have it available. We will have an 8% interest compounded quarterly, and we want to have $3 million in 3 years from now. So we want to know, what do we have to invest now to get that $3 million? First thing you have to do is find how many, what is a percent per period. So there are 4, we have 8%, so it's 2% per period. We know that it's 3 years, we know that it's quarterly, so 3 years times 4 periods per year, there are a total of 12. Okay, with that information, find what your factor is from this future present value table on page 358. You're looking at 2%, looking at 12.
Can we still multiply that by the?
Yep. You take that figure, which should be 0.78849. Everybody find it okay? And multiply it times the 3 million. So we would have to invest today $2,365,470 to get 3 million in 3 years at 8%. Again, if you look at the table on page 358, oh, I want to do, I'm sorry, let's do an example. No. It's the same one. Never mind. Our table on page 358, it only goes for 25 periods. So again, it may be that we have extended periods, and we would do exactly the same thing that we did in the future value situation. For the stated interest rate per period, we find the 2 table factors that represent half are values as close as possible to half of the periods required. Then we multiply those 2 table factors from step 1 together to get a new factor, and we round to 5, so it's exactly the same thing. So let's see how this one works. Calculate a new table factor and find the present value of 8,500. So we want 8,500 in the future if the interest rate is 6% compounded quarterly for 10 years. So I want you to figure what is the percent per year and what's the compounding periods. Find that first. The percents per period, and then how many periods do we have? What's the percent per period?
0.6.
There's
Or
quarterly,
oh,
it's 1.5. 1.5. It's 10 years times 4 is 40. So we know we don't have 40 on our table. What's the closest thing to it when we have it? 20. Okay, 20 years. So then we would look at 1.5 for 20-year period. So look on your schedule, on your table, and find it. 1.5 and 20. So we take that factor, which is 0.74247, and we multiply it by that factor again, because that would be the other 20 periods. We get our new factor, we round it, 1, 2, 3, 4, 5. Okay, the next number is 1, so this would be our factor right here, stopping at the 6. And we would multiply that times the 8,500. And so we would need to invest $4,685.71 today for 10 years at 6% compounded interest to have $8,500 in 10 years.
So when you're halving it, you're halving the compound?
You're halving the compound periods because we can't look on our table and find 40. So it says to find, you take half of it and then you get the one that's closest to it. Well, half of that's 20, so that's easy. Okay. But you may have to determine which factor you want to take, which compounding period you want. If it's a 20 and a half, let's say, or something like that. Okay. We're going to be on page 360. You're going to be skipping 11.8. You'll be skipping 11.8. And you'll also on page 363, on page 363, you'll be skipping number 27, 28, number 29D. And I think I have put this into your schedule. I think I put some things that you're going to be skipping, but just let you know. Okay, we're going to review, and so I have some problems that I want you to work. A firm is planning to build 5 homes, each costing $125,000 in 2.5 years. The bank pays 6% interest compound semi-annually. How much should the firm invest now to have a sufficient funds to build the homes in the future? Okay. So we know what amount, we're looking at an amount that we need in the future. So you're going to be using a present value tables. So you need to find out how much you need and then find out your interest per period and your compound period. Then find your factor. Okay, so we have 5 times 125, 625. The interest per periods, how many periods do we have? I mean percent, I'm sorry. What is the percent per period? If it's 6% and it's done semi-annually, that's 2 times you're getting paid. So it's 2 divided into 6%, so it's 3% per year, okay, per period. Compounding periods, it's 2.5 years, and we have 2 periods, so now it's 10. We're looking at 10 compounding periods. So now we got 3%, 5 compounding periods. So now look up your factor if you need to relook up your factor. So your factor would be 0.86261. Multiply that times what we need, 625,000. So we would need to invest 539,131.25 cents to have what we need in 2.5 years. Okay, try this next one. As a saving plans for college, a family deposited $10,000 in an account paying 8% compounded annually when their son was born. How much will the account be worth when their son is 18 years old? So are we going to use present value tables or future value tables? Future, correct. Okay. So remember, first thing you need to do is determine a number of the percentage what per period, number of periods, and then find your factor. You need to determine is the interest rate per period. So we had 8%. How many periods did we have? One. So it's 8%. How many compounding periods did we have? Because we had 18 times 1 would be 18. Now with that information, if you didn't look it up, if you didn't get those two right, look up and find on the future value table 8% for 18 compounding periods. And you should get 3.99602. Multiply that times the 10,000. So if they invest $10,000 at the time their son was born, and then if they can find 8% compounded interest, they're doing lucky, but they would have $39,960.20. So they need to send their son to a community college because that's about what it would pay, right? Okay, next one. A firm deposited $500,000 in an account earning 12% compounded monthly to pay for the future construction of a warehouse. How much will be available for the project in 2.5 years? Are we looking at future or present table? Because we know how much we're depositing, so we're using future. Okay, on the interest rate per period, what was the interest rate per period? 1%. We took the 12, it was monthly, so we divide it by 12, so it's 1%. So that's what you're looking across the top of your table for. The compounding periods, how many times will we get that? We get it 12 times how many years? 2.5 times 12, so it's 30. Okay, now this is one that you had to figure, so you divided the 30 in half. Okay, so you got 15. So you'd look at 15 at 1%, and you got your 1.16097. You multiply that by itself again, and then that gave you 1.34785. And that's what you would use as your factor. Times 500 you'd have $673,925.65. Anyone have any questions or not understand something about it? Okay.
I'll get it when I get home.
Well, you're right. I mean, once you look at it, you'll be okay. Okay, we got one more. Okay, a bank is offering a 6-year certificate of deposit, that's a CD, at 4% interest compounded quarterly. What is the annual percentage yield for an investment of $8,000? So remember, you're going to have to go through the same process, finding the interest rate per period, the compounding period, finding the factors, multiplying it, so you can find what is that interest rate, and then divide it.
So we
Do
still
the
have to
rest
find
of
those two factors?
Yep. Okay, what you would have is the interest rate per period, 4% quarterly, 1%. But we're looking for 1 year, so compounding period is 1 times 4, would be 4. Okay. So we'd look up our factor, it'd be 1.04060 times 8,000, and so we get 324.80. We want to find out what that interest is, so we subtract the 8,000. So once we get the 324.80, that's for 1 year. We can divide that by the 8,000, and that gives us the rate, 4.05% APY. Okay. All right, go ahead and spend the rest of the class time working on what you need to.